So let's navigate on to talking about how to do your lab worksheet for tree competition lab, right? Again, this is corresponding to the worksheet in chapter 8 of your textbook. In order to complete this lab activity, this worksheet, you will also need to read chapter 9 of your lab manual. Okay, so let's go on and move on from question to question, right? So first question is place the Google Earth image showing Kava Pond and tree competition study site. If necessary, resize to fit the page. Insert a caption. Now, you know how to do this already. You have done this several times in your assignments. Okay. In my previous video, I have shown you um, the coordinates of this location. So take a look back at that video, take those points and plot that on Google Earth, right? And also make sure when you do this that that your map shows the location of the Kava Pond and the woodlot, right? And drop a pin by the woodlot and mark it as woodlot. You can also drop a pin by Kava Pond and mark that as Kava Pond. And then just take the image and copy it over here and put a caption, right? In the caption, remember, it has to be pretty meaningful, right? You need to add figure 1, right? And then tree competition study site, Kava Pond, Bridgewater, Massachusetts. Feel free to make your figure as meaningful as possible. Okay, you should by now you should know how to add a good map of your study site. Okay, and then question number 2 is about, in the lab manual, it says exchange data with the other research teams from your laboratory section so that you have a complete set of blah 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 blah. So question number 2, you don't need to do that because A, you cannot do it. I'm providing you all the data. There is no combination or mixing up or combining data. That is not happening, right? So just skip question number 2. Question number 3, describe what relationships do you predict to find between the focal tree and its nearest neighbors. If there is a strong competition between the trees, make sure to address each comparison listed below in your answer. Right. So describe what relationships do you predict to find between the focal tree and its nearest neighbors if there is a strong competition between the trees. So assuming that all the trees you measured were competing, right? Assuming that there is competition, both interspecific and intraspecific. What kind of relationships would you expect between these 4 variables? That is the question. So in order to answer that, you should know what competition is. Competition is 2 individuals battling, for or competing for a common critical biological resource. For example, right, if you look at this particular point, if there is competition, right, between your focal pine tree and the intra-specific neighbor, that is another pine tree that you measured, right? If there's competition between those two, there will be a greater distance between the 2 species, right? Because of competition, right? The competition between the same in competition within a particular species, right, will increase the distance between those two, right? If because of competition, some of the younger individuals that are weaker competitors actually die, right? So they cease to exist. As a result, stronger competitive forces between 2 individuals, two trees, will actually increase the distance between them. So that's actually one thing to consider here, right? That's kind of a hint for you, right? So the same thing happens actually if it is 2 individuals of 2 different species, right? If there is interspecific competition, right, between those 2 species, the distance between those 2 trees will also increase, right? If there is less competition, if the competition doesn't exist, right, there is nothing to prevent the inter-neighbor distance closing up. Okay, so that's actually one hint for you to think here. Well, with respect to CBH versus distance, right? Circumference at breast height versus distance between the two trees. Well, how would you expect those two the relationship between those two variables to vary? A tree with a greater circumference at breast height is a larger tree, a mature tree that has a well established, right? So if it is a larger and a mature tree, it is going to be competitively more dominant and superior, right? So if there is interspecific competition with increasing circumference at breast height, the intraspecific as well as interspecific neighborhood distance will also increase. Okay, so uh, in other words, if competition exists, whether it is intra-specific or inter-specific, right, you will see a positive correlation between circumference at breast height and the inter-neighbor distance or between neighbor distance. Okay, so that's actually one hint towards you, right? So try to apply the same logic, right, between circumference and circumference, right? What would you expect circumference of the focal tree? Um, what would you expect the circumference of the neighbor to happen when the focal tree circumference increases if there is competition, right? Apply the same principle and make a prediction, right, for all four of them. Right, so I gave you my prediction for C and D, right? For C and D, I would say if there is competition, um, I expect a positive, strong correlation between the focal tree CBH and the neighbor distance. Okay, I tell me the same, a similar prediction for A and B. Right? What would you expect to find if competition exists? Question number 4 is very easy. Write down the GPS coordinates that I have already given you, right? Question number 5 involves some math. So in order to do that, let's go to your Excel sheet. Where do you find your Excel sheet? This is your lab Blackboard page, right? And you go to course content. You navigate to tree competition activity, right? And your data for this particular lab is provided. Your tree competition data is provided here. Okay, um, and this is actually the worksheet location, and this is where you submit it. Okay, you should be very familiar with the Blackboard orientation right now. Let's go back to our Excel sheet and started doing some analysis. Okay, so this is actually the Excel sheet that you will be working on, and I actually have so this is how you see it, right? First column, the group, and then I kind of explain all of these columns in the previous lecture. So it is exactly the same, right, with data. Now, and these are the 4 things that you have to calculate in terms of correlation coefficients. Let's take a one quick look at this question set again. Right, so calculate and enter the correlation coefficients for each of these 4 variables or 4 comparisons, right? So what is a correlation coefficient first? That's extremely important to understand what that is, right? So correlation coefficient first, it's kind of a plot between 2 different variables. Think about this first, right? So you are actually doing a correlation, which is a where you are creating a plot, right, between any given variables, right? So in your case, you are looking at circumference at breast height of pine tree, of a focal pine tree, versus 4 other variables, right? And so you plot one in each axis, right? And these dots are actually your different values. And then you draw the line of best fit, which is the blue line over here. And the correlation coefficient is a mathematical number. It's actually a particular value that ranges between, it has a particular minimum and a maximum value, and right, and what are those particular values that correlation coefficient can take? ranges between -1 across 0 to +1, right? -1 to +1, right? So if you look at this particular example over here, right, you're looking at a positive strong correlation, right? So this will have a correlation coefficient, letter r, lowercase r, that is closer to +1, right? It may be something like 0.9. Okay, and then in this example, you're looking at still a positive correlation, right? You can see that when x increases, y increases, right? So because of that, it's a positive, right? Now, if you look at closely, how do we know it's weak? Why do I say it's weak? Compare to this one, you can say that all the data points over here perfectly fits on this regression line. On this case, you see that actually the data points are kind of scattered, right? They do actually sort of show some sort of a trend line, right? But the fit of all the data points is not as perfect as in the previous case. So because of that, we say there is a positive correlation, because when x increases, so does y, but it's weak. The data points don't form a clear-cut trend. So that's why I say it's weak. So a weak correlation will have a value closer to 0, right? Further away from 1, right? And then strong negative correlations, right? So in this situation, what you see is when x increases, y declines. At the same time, you see that those data points are lining up perfectly, right? So because of that, it's a strong correlation, strong negative. So the correlation coefficient, lowercase r, will have a value closer to 1, okay? Something like -0.9. Over here, we are looking at a weak negative correlation. Why negative? When x increases, y declines. Why weak? Because the data points don't perfectly align, right? So as a result, it's a weak negative correlation. Since it's weak, your correlation coefficient is going to be further away from 1. Right, and then on this one we actually have a moderately negative correlation, right? In why we call it moderate negative, because well, negative because when x increases, y declines. Why is it moderate negative? Because the data aligns better than in a weaker correlation, right? Data points align on a declining slope, but not as strong as in a strong correlation, not perfectly on a single line, but better than in a weaker correlation. So that's why we call this a moderately negative correlation. And then no correlation is a situation that you see over here. When x increases, y stays unchanged, right? And you can see the data points are all over the plot, right? It shows absolutely no particular trend, right? And the trend line itself is a flat curve, a flat line. In this situation, the actual correlation coefficient is much closer to 0, and in certain cases it will be 0, right? So now you have a relatively good idea about what is a correlation coefficient is. Correlation coefficient will tell you the strength of the relationship. Correlation coefficient will tell you the strength of the relationship between the two variables you are measuring. Okay, now let's try to do these measurements over here, right? So in this graph, I have actually created this particular component for you to calculate the correlation coefficient, right? So I'm going to keep my cell in where I want to calculate it. What am I going to measure over here? Focal tree CBH to CBH of the nearest intra-specific neighbor. So my column C is focal tree CBH, and nearest intra-specific neighbor is actually column D. Yeah, I think it is column D. Yeah, column D is intra-specific nearest neighbor circumference. Yeah, so I needed to compare column C with column D in order to get my correlation coefficient for the first part. Okay, so what I'm going to do, I'm going to keep my cursor over here. I will go over here to the formula bar, right? And I will type equals correlation, and then when you type CORR, this thing pops up, right? And I'm going to double click that, right? And then I'm going to type, and then it prompts for array 1 and array 2. What is my array 1? Focal tree circumference, right? I'm just going to select all the data for that, right? Now see, I only selected the data, I did not select the column heading, okay? And then I'm going to put a comma, and then I'm going to select the second array, which is my column D, which includes the data for intra-specific nearest neighbor circumference, right? I'm going to select that, and I'm going to close that parenthesis. And I'm just going to hit this check mark, right? And there you go. That is actually my correlation coefficient for focal tree CBH and the CBH of the nearest neighbor, right? And I will do the second one for you as well. It's going to be focal tree CBH and the CBH of the nearest interspecific neighbor, okay? So focal tree is this one, column, still it's column C, versus interspecific CBH. So interspecific CBH is actually column F, right? Interspecific nearest neighbor circumference. So how do I do that? Go to the formula bar, equals CORREL, right? Nope, that's not correct. CORREL, open parenthesis, array 1, focal tree, right? And then comma, array 2 is going to be interspecific circumference. So column F. Right, and I'm actually right there, like there, right? And you can actually use the mouse, and I was using my arrow keys and shift. For you, I recommend just using the mouse to highlight that. Close the parentheses and hit enter, right? Right. That's interesting actually. For that one, you actually have a negative correlation coefficient. For the previous one, you had a positive correlation coefficient, right? So do the same for the other two, right? And I'm not going to demonstrate it because, you know, it's just following the same thing you already have done. Now I have two of those values, right? And let's go to my worksheet over here, right? Question number 5, calculate and enter the correlation coefficient. So just copy and paste those values, right? When you copy and paste, do not forget to copy the negative sign, or if there is a negative sign. Question 6, the chapter 9 provides the critical values for Pearson's correlation coefficient R for an alpha of 0.05, right? Identify which of the correlation coefficients in question number 5 exceeded the critical value. Interpret your results in light of these critical values. Which correlations were significant? Okay, now let's try to answer that question. Well, before answering that question, let's try to understand what that question is. So over here you do see some R squared correlation coefficient R values. Well, you know, based on the sign, whether that relationship between the two variables is positive or negative, right? But how do you know whether it's strong or weak, right? We haven't created the plots yet. We haven't did a line of best fit. We just estimated the correlation coefficient. So what we're trying to tell you over here is, how do you know whether the correlation coefficients you extracted is significant, right? That's when that 0.05 comes into play, right? The alpha value or the confidence interval is important in this case, right? You may have a positive or negative correlation, but that may not be that significant. So that's what we're trying to understand here with respect to that particular question. Now, So in order to answer question number 6, right, look at page 98 of chapter 9, right, and read that particular page that talks about correlations, right, and to the bottom of that we list different significant thresholds, right, for different sample sizes, right. Now if you read that, when the sample size is 15, the threshold is 0.514, right? When the sample size is 20, 0.444, right? And our sample size is actually 45. Remember, you actually had 15 multiplied by 4, and if you counted my Excel sheet, you are going to see 45 data points. So that is your N. Sample size is 45. The corresponding threshold for R value for that particular sample size is 0.294. Okay, so let's put it over here, right? When N equals 45 and alpha equals 0.05, right? The corresponding threshold for R is 0.294, right? So what you're going to do is compare this particular R value, the tabulated R value, with your calculated R value, right? So let's compare the first two that you already have. Well, are any of them greater than our threshold R value? No, our threshold or tabulated R value is greater than both of these R values, right? And as a result, none of these two values are significant, right? Now again, when you compare, disregard the sign, right? The sign, like, you might argue like minus 0.19 is, but anyways lower than a positive value. But no, when you compare the tabulated R or this threshold R with calculated R, disregard the negative sign, okay? Just compare the absolute numbers. Again, looking at the absolute numbers, no, none, both of those are lower than my threshold, right? So my inference is, none of these correlations are significant, right? One is positive, one is negative, but none of them are significant at when alpha is 0.05. Okay, now let's go back over here. And try to understand what's going on over there. So over here, like I will do you, I will actually demonstrate one by an example, right? For the very first one, focal tree CBH versus intra-specific CBH, right? It's actually this particular value, right? And what I'm going to do over here is I will paste that first, right? Correlation coefficient between focal tree CBH and CBH of the same species is this, right? At 0.05, you can say actually 0.05 is 95% confident interval. At 95% confident interval, right? And you know this how? Well, 0.05, 100 minus 0.05 is 5%, right? 100 minus 5 is 95%. So at 95% confident interval, right, when sample size is 45, right, the tabulated correlation coefficient is going to be 0.294, right? Therefore, although there is a positive, right, correlation between CBH of the same species, right, in this case pine trees, this correlation is not significant at 95% confident interval, right? As simple as that. And also, okay, so now we mentioned that there is a positive correlation, right? And we mentioned that this is not significant, right? And we didn't mention the strength of the correlation. Now, how do we determine the strength of the correlation? Well, look at that number we extracted over here, right? The calculated R squared, right? Calculated correlation coefficient. Now, I mentioned if the correlation is strong, that value is going to be closer to 1, right? And well, obviously 0.06 is not closer to 1, right? It's actually further away from 1. So we can actually also mention this correlation is weak. So here I'm going to say, therefore, although there is a positive, weak correlation between CBH of the same species, this correlation is not significant at 95% confident interval. So this is actually a more comprehensive interpretation of your results. So again, what you have to do is just look at your R squared values and then, like interpret your observations in the same way. There are 4 R values that you actually calculated, 4 correlation coefficients. Interpret all 4 of them in the same way. Let's look at the next question, question number 7. Using Excel, prepare and attach to this worksheet scatter plots showing the relationship between each of the 4 pairs of variables. Okay, let's go to this Excel sheet and I will show you by a demonstration how to do that, right? Put your cursor somewhere else, right? And go to insert and go to in this chart options, pick this scatter plot option, right? When you hover around this one, it will say insert scatter, right? And then pick that particular one, and it will actually create an empty graph. That's okay, right? So you right click and then you go to select data, right? And now you can actually have to add 2 axes. First, add, right? Series name, well, you can call it this, right? So that you can identify what series it is coming from. I'm referring to this particular cell, focal tree CBH versus CBH of this of another pine, right? And my x-axis, I'm going to use my focal tree circumference as my x-axis. So I'm going to drag and drop, right? And then for series Y, what I'm going to do is I will go back, right? And the series Y in this case, I wanted the intra-specific circumference, which is actually this one, right? I select all the data, right? All 45 data columns, right? And then I'm going to click OK. Right now, actually I have done that, right? So you can now click OK, right? And let's make it a little bit bigger, right? Still, well, we kind of see a data cloud over here, and you don't see any pattern in that data cloud, right? And remember, you have to label your x and y axes, right? My x-axis was the focal tree CBH. So I'm going to select the plot, add chart element, right? Select the plot, chart design, add chart element, chart axes, and I'm looking for the primary horizontal axis. So not axes, sorry, not axes, chart elements, axis titles. I always mix that up because they are very similar in name. And then I actually delete that default one and type circum. I can actually say CBH, right? You should type it out actually. CBH of, I don't want you to use acronyms, make it more meaningful. I'm just being lazy. CBH of the focal pine tree, right? And also put the units over here, right? And then again go to the y-axis, right? Select the plot, chart design, add chart element, axis titles, and what is this going to be? This is going to be CBH. Again, I won't type it out. Circumference at breast height of, or intraspecific CBH, right? Again, put units, right? And that's it. Still, we have to put a trend line, a line of best fit, right? So again, what we do is select the chart, chart design, add chart elements, trend line. And there are several options, and there are like different purposes or different ways we fix it. But for simplicity, I'm going to add a simple linear trend line. Okay, and you can see this. Let me actually enlarge this graph, right? You can actually see this particular line, and I don't like the way it is formatted. I'm going to select that line, right, and right click and pick format trend line, right, and then this thing pops up, right, and then I'm going to go to this fill and lines option, and I'm going to ask for a solid line, right, and I'm going to make it blue. Blue is fine because my data points are in blue, and I wanted not the dash type, I wanted the solid type, right, and let's make that line a little bit thicker. There you go, you have it, right. There are still certain problems with that. Okay, you can actually think about what else is missing over here. You don't have to have a legend over here because it's just one graph, right, one data set, right, and I don't like this caption over here. So what you should do is when you copy and paste this into your worksheet, get rid of this and add a meaningful caption, right? So I know I'm looking at focal tree CBH and CBH of the nearest intraspecific neighbor. So I'm going to actually just copy that content, right, and delete the rest of it, right, and going over here, copy as a picture, right, as shown on the screen, and go over here and dump it right over here, right. That's actually my first point, and resize it so it actually fits better, right. Make sure, like, when you resize it, don't make it way too small, like that probably is way too small, right. And then caption figure 2, it's figure 2 because my figure 1 is the map, right. What am I looking at over here? The correlation between CBH, I'm being lazy, CBH of focal pine tree and CBH of other intraspecific, CBH of intraspecific trees, or intraspecific nearest neighbor, right. And then, well, then that's it actually, right. And you can actually see, if you look at this graph now, right, comparing this to my other conceptual figures I showed you over here, right, there's a trend line. It's almost flat, right, very similar to what you see over here, right? Yeah, it's slightly trending positively, but it's almost a flat line, right? That's number one. Number two, right? The data points are all lower, right? They are not aligning anywhere close to the actual trend line. So that actually tells you two different things. This is very weakly there is a positive relationship which is almost like a flat line. Because it's like a flat line, this will not be a significant correlation, right? And because the data points are all over the plot, not aligning anywhere close to the trend line, it's weak, right? That's again, it's kind of, this is the best way to understand what's going on over here. And I will do another example for the graphs for you, right? And I'm going to make this smaller so that I'll have more space to mess with, right? I will this time look at this one, right? Focal tree CBH and CBH of the no, I will do something else. I'll look at the distance. Focal tree CBH and distance to the nearest intraspecific neighbor. Okay, so what I do, I put my cell somewhere else, right? Insert. I want scatter plots. I pick the first option and then I have this empty plot. That's okay. Now what you do is you right click, you go to select data and add, right? Series name, well, what do I want to call it? I'm going to pick this particular cell because it actually describes what I'm looking at. And then I go to x-axis values. My x-axis is always going to be column C, so I select the entire thing. And then I go to Y. Y-axis is going to be what, right? I'm looking at, if you look at this particular point, focal tree CBH versus distance to the nearest intraspecific neighbor. So distance to nearest intraspecific is actually this. Intraspecific, nearest neighbor, distance, right? So I'm going to select all of that data, right? Make sure to select all the numbers. Make sure not to select the column heading, right? And then I hit OK. And hit OK again, right? So yeah, you have what you need, right? Again, format your axes, select the plot, chart design, chart elements, axis titles. First, primary vertical, primary horizontal, that is going to be always focal pine CBH, right? Mention the units. Again, select the plot, chart design, chart elements, yada yada yada. Axis titles, vertical, right? That's going to be actually now a distance, right? Nearest neighbor distance. Like, I'm being lazy, don't put NND. You are going to type out nearest neighbor distance, or better yet, intra. I think it was intraspecific. Yeah, intra specific nearest neighbor distance. And remember, now put units. This is going to be centimeters, I believe. And now we need a trend line. Select the plot again. Chart elements, trend line, linear, right? I want to format that trend line, right? I go to format trend line. Go for this fill and line option. I need a solid line and I want to make it dash type. No dash type, I want a solid, right? And then I want to increase the thickness of that by increasing the width. And I got it. Well, that one again, you can see slightly positive, but almost a flat line, right? So, and again, you can see the data points are all over the place. So you are looking at slightly positive, weak correlation. And because it's actually almost flat, only slightly positive, this is not going to be a significant trend. And because the data is all over the place, not along the trend line, you are going to have a weak, slightly positive correlation that is not significant. So that's actually, I am demonstrating two of them now, right? And then copy and paste it over here. So Keep doing all the other plots, right? Don't forget to add the meaningful caption. And question number 8, what evidence did you find for competition occurring in the study woodlot? So this one is actually going to be answered based on whether two things, right? Do you have significant correlation coefficients, right? I mean, if you don't have any evidence, you are going to say, no, I do not have any evidence, right? If you do have evidence, like remember, I didn't run all the data, so there maybe you might find some evidence, right? So mention you have competition evidence for competition for what? Is it interspecific? Is it intraspecific, right? And then mention based on what, right? You remember you did actually test for two different types. One, you compared CBH to CBH, then the other hand you compared CBH to distance, right? So out of those, which one provide evidence for competition, right? And say which one does not. If none of them provide evidence for competition, you can actually mention it in one simple sentence, right? There is no evidence for inter or intraspecific competition. Be clear, right? Don't say no evidence. No, like that's a meaningless, stupid sentence. No, mention no evidence for either intra or interspecific competition for any of the variables, right? And then if you have evidence, clearly mention is it whether it is inter or intra and based on what two variables, right? So that's actually what your answer should be for question number 8, right? Now, like I always mention, do elaborate, right? Do not just throw in random meaningless sentences, right? Be precise, be to the point, right? And in fact, it's a thought process, right? It's actually, you know, and what I'm expecting you to do is write your thought process. It's not that hard. Number 9, when managing a woodlot to increase economic yield, what steps could be taken to reduce potential negative effects of competition on the yield? So what happens? Let's say you own a forest and you are a private forest owner and you manage that for timber harvesting, and that happens a lot in the United States, right? USDA, United States Department of Agriculture, US Forest Service manages lots of forests to extract timber sustainably and sell it and makes money out of it. So that's actually a federal business as well as a private business. So in this way, you're actually promoting sustainable resource use. At the same time, you're actually conserving biodiversity, right? So when you manage a woodland, you have to actually make sure that all your timber is actually large enough to be harvested, right? Large enough to have an economic value for lumber, right? So in order to do that, you have to minimize competition. If competition exists, what happens is actually you will end up with thinner trees, right? Because that's what competition do, right? It will actually make the CBH much thinner, much smaller. And then if the CBH is smaller, because when you compete, there's not enough resources. And remember, competition is not a win-win. Competition is lose-lose. Both competitors lose when they're competing for a particular resource, right? There's a competitively dominant one and there's a competitively subordinate one. You might think, oh, during competition, the competitively dominant species or the competitively dominant tree wins over the subordinate. Not really, right? Competitively dominant species will still lose some resources because the competitively weaker one will still extract some resources, right? So it's a lose-lose. Competition is a negative interaction, okay? So because of that, overall, because of competition, you will end up having smaller trees with a smaller diameter, smaller circumference, and that is actually a commercially not good. It's not harvestable, right? So my question to you is, how would you minimize competition? Could you actually increase the distance between trees, right? You can actually, when you plant them, you can actually plant seeds or seed trees, seedlings, maintaining a particular minimum distance between them, right? In that way, you actually space. So in that way, you actually have two different root structures, you know, that are spatial. They are not competing for the same amount of resources, right? So that's one way to do it. keep a particular interspecific distance so that they are not competing for resources. Okay, maybe you can actually, before you plant, you can do some sort of a soil restoration, right? To increase the soil resources for these plants, right? That's actually that's another way to decrease competition, right? So think like a biologist. How do I decrease competition, right? And another way may be actually thinning the forest, right? You could actually selectively remove weaker competitors, right? You can actually first grow your seed trees, let them grow, let them mature, and then you can initially pick what trees actually have a smaller diameter, what trees are weak, right? And cut them, remove them, right? And so that that tree will no longer earth up resources that could have been used by another tree. So think like a biologist and tell me, how would you minimize competition to increase the yield? Okay. And question number 10, DBH, diameter at breast height. DBH, diameter at breast height, is the most common metric used in forestry. We use circumference at breast height instead of diameter at breast height. So why is the use of circumference at breast height an acceptable substitute for diameter at breast height? Well, this is more of a mathematical question. So we are right. Like actually, we use diameter tapes. When you wrap the diameter tape around the tree's circumference, what you actually measure is the diameter, right? And there are calipers you can actually use to do the same, where you actually hold the caliper, kind of putting the caliper's jaws across the tree's maximum diameter, and you actually directly measure the diameter. We didn't do that. We actually measured the circumference. Why is it reasonable? Well, because mathematically there's a direct correlation between the CBH and the DBH, right? That's simply the answer to that question. Number 11, in a forest ecosystem, for what kind of resources might trees be in competition for? Well, it's a simple biological condition, right? What do you think trees competed for? Well, how do you know? Then ask yourself, well, what do they compete for? Compete for resources. Well, what are the critical biological resources for trees? What do trees do? They photosynthesize. Okay, what do you require for photosynthesis? Carbon dioxide, water, sunlight. Well, I can hardly imagine trees competing for carbon dioxide, because most of the carbon dioxide they use for photosynthesis is the respiratory carbon dioxide. So no, carbon dioxide is not a problem. They won't compete for carbon dioxide. And with industrial activities and with the global carbon trends, we have actually more than enough carbon in the atmosphere. They compete for water, they could compete for light, right? And also they could compete for minerals. They could also compete for physical root space, right? So like that, like for the substrate. So think about the critical biological resources for plant growth and which out of them which are actually limited. Competition only happens if the resources are limited. That's why carbon dioxide is not a resource they compete for. So think like that, right? And answer the question number 11. Well, folks, that's all I have for you. This is due in a week, and this is a very easy lab. If you have any questions, you know where to find me in office hours. All right, guys, have fun. Bye bye.